In this video, I'm going to explain replace by MEX from the Codeforces Global Round 9. In this question, we have been given n integers and we have to do several operations and make it an array that is non-decreasing. And we have to do it in at most 2n operations. Now the operation that has been provided to us is that we can replace any of the elements in the array with the MEX of all the elements. Now what is MEX? MEX is actually the minimum excluded of an array. That means that it is the smallest non-negative integer that does not belong to the array. So here are some of the examples that are given. In this array we can see that the minimum excluded is going to be 0. In this one it is 2 because 0 and 1 are already there, and in this one it is 4 because 0, 1, 2, 3 all are present in this array. So what we have to do is we have to replace some of the elements by MEX of the elements, MEX of all the elements, and we have to convert the original array into a non-decreasing one, and we have to do this in at most 2n operations. A fact that should probably be noted is that for any given array of length n, for any array of length n, the MEX is always between 0 and n inclusive. So you can think about it like this. If suppose the array is 0 till n minus 1, all the elements from 0 to n minus 1 are there. This is a length n array, then the MEX is definitely going to be n. If suppose we miss any of the, if we miss some of the elements in this particular array and replace it by something else, then definitely the MEX is going to be between 0 and n minus 1. So this is always true. Now we can use this observation to build an array which is like this. Now this follows the property of non-decreasing because it's increasing. So if we are able to convert the original array into something like this in less than 2n operations, we are going to achieve our aim. So the question is, can we build it in less than 2n operations? Let's take an example and try to convert this array V, which is of length 9, into an array which is non-decreasing, specifically of this particular format. The reason why we are trying to convert this into this particular format is we know that the MEX of any element, any given array is always going to be between 0 and n inclusive. So whenever we find MEX to be less than n, I'm just going to replace V of MEX with MEX. The reason is this particular array is of the form V of I equals I. So whenever I find MEX to be less than n, I'm just going to replace MEX in that particular position. So let's try and understand this by iterating over this array and performing the operations while doing so. So I have this. In the next iteration, my MEX is going to be 3 and my array is going to look like, I replace this one with 3. This is a 0 indexed array, so it's going to be 0, 1, 2, 3, 4, 5, 8. These are the indices. So I replaced V of 3 with 3. I do this operations again and again. Now the MEX is going to be 5 because I have 0, 1, 2, 3, 4. So after a while, I'm going to reach this particular array, and now my MEX is equal to 9. Now MEX equals to 9 means that MEX is equal to n in this case. So what should be my next step? So what I'm going to do is I'm going to replace any position which is not correct with 9. Now all these positions 3, 4, 5, 6, 7, 8 are in their correct positions. So I don't need to touch any of these. However, 2, 0 and 1 are not in their correct positions. So what I'm going to do is I'm going to find which of the element is not in the correct position, and I'm going to replace it with this. Okay, so the first element I got over here is 2, so I'm going to just replace 2 with 9. So now what I get is that the next MEX that I receive over here is definitely going to be between 0 and n minus 1, because I've already replaced a position with n. So the next MEX is 2. Now I can continue my iterations just as I was doing before. So I'm going to replace v of 2 with 2, and finally I have for 1, which is and for 0 it's going to be corrected. So basically what we can understand is whenever I'm finding a MEX which is less than n, I just need one operation to replace the value with the correct value, replace the element with the correct value. So whenever I find MEX equals to n, I basically take two operations to correct the place. So definitely my total number of operations is going to be less than 2n. So this was the explanation of the algorithm that I'm going to use in my code. And for watching the code, you can check the link in the description. It's a separate video. Thank you and have a great day.